2025 academic decathlon mathematics subject, and this is worksheet 5. I will say that the order that they are covering this material is quite odd. We just went from solving quadratic equations to now slope. All right, slope is relatively simple. We know that slope of a line is calculated by the rate of change, and that rate of change is the delta in y's over the delta in x's. Sorry, that's a horrible x. And we say delta in the meaning the term change. Delta means change. The change, and we know that as the rise over the run, or the difference of x's, the difference of y's, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And your sub talks about point, so this is 0.1. Now let's move that up. This is 0.1. This is going to be 0.2. It doesn't matter, they are interchangeable. So this is your x sub 1, y sub 1, x sub 2, y sub 2. And what this is talking about is your x value in your first point, your y value in your first point. This is your x value in your second point, and your y value. So if we substitute these values into this, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that gives us 2 over 5. Or 2/5. So the slope of the line containing those 2 points is 2/5. So we again, x sub 1, y sub 1, x sub 2, y sub 2. My y sub 2 value is 12 minus my y sub 1. Then I have -5 minus my x sub 1. This is where most students will make their mistake, is they will misinterpret this negative in this formula, y sub 2 minus y sub 1, x sub 2 minus x sub 1. They will think that this negative is the negative for the coordinate, which is not the case. 12 minus 7 is 5, and 5 minus 5 is positive 5, so that gives us 0, and this is, you can give a couple of answers. It's no slope. Sorry, it is undefined. The slope is undefined. No solution, no slope. Different from 0. 0 is a slope. No slope is not. So here we are again. This is x sub 1, y sub 1, x sub 2, y sub 2. All points are written x comma y. So we have -2 minus -2 over 18 minus 8. And this gives us 0 over 10, which equals 0, which is the value of the slope. Calculate, this is, I saw this when I was preparing this. This is very interesting that we have radical forms. But you still do the same thing. 6 radical 3 minus 2 radical 3 over 0 minus -3, which gives us 4 radical 3 over 3. And that is an interesting slope. I don't think I've ever seen a slope with a radical. All right, next part. Those were just our warm-up problems. So hence why it was relatively simple. Now, in the worksheet, in the main worksheet, we're going to fill in the table by creating equations for lines. There are 3 different forms. We have slope-intercept form, which is y equals mx plus b. We have point slope form, which is y minus y sub 1 equals m times the quantity x minus x sub 1. And then we have standard form, which is ax plus by equals c. So, all right, create the equation of a line that contains these 2 points. So we tend to start off with this equation. We want to find the slope. So this being x sub 1, y sub 1, x sub 2, y sub 2. Let's find the slope. So 5 minus negative 7 over 1 minus negative 5, which will give me 12 over 6, or 2. So that's going to be my slope of the line. And now I could do point slope. So let's do that actually, because we have the slope and we have a point. So we'll have y minus y sub 1, which is minus y sub 1 equals m, the slope, times the quantity x minus x sub 1. And let's simplify this. And we simplify it just to the point of putting it in, getting rid of those double signs. So this would be a point slope equation. So this would be in point slope form. Now, there are an infinite number of solutions to write an equation in point slope form because there are an infinite number of points. They will all have the same slope, but there are an infinite number of solutions, so there are many different numbers that can go into there. We could have chosen 1, 5. So this is point slope. And now I'm going to use point slope to get into slope intercept. And to do slope intercept, let's do that in blue. We start with the point slope form. And now slope intercept is, we're going to distribute that. And that's 2x plus 10. And then we set it equal to y. So we'll minus 7. Y equals 2x plus 3. And this is going to be the slope intercept form. Okay, so that's nice and easy. And then when we want to turn it into standard form, we're going to take this slope intercept form, y equals 2x plus 3. We're going to minus 2x because x and y need to be on the same side. However, when you get in standard form, a, b, and c must be integers, positive whole numbers or their opposites, and a needs to be positive. So we're going to have to multiply this by -1, multiply everything by -1 in order to get my a value to be positive, because my a value is -2, my b value is +1, my c value is 3. So we would get 2x minus y equals -3. That would be in standard form. So that's how we do this problem. Relatively easy. Now we have the same points. We're provided points. So x sub 1, y sub 1, x sub 2, y sub 2. Let's find the slope first. So the slope is going to be 8 minus 2 over 6 minus -6, which is going to be 6 over 12, which is 1/2. Okay, now let's take point slope. So we'll take a point. We'll take 6, 8 this time. So y minus 8 equals my slope times the quantity x minus 6. So that is point slope form. And now if I want to take point slope and turn it into slope intercept, I'm going to take y minus 8 equals 1/2 times x minus 6. We'll distribute that 1/2 to get 1/2 x minus 3. We'll add 8. And the equation is y equals 1/2 x plus 5. And that's going to be slope intercept form. And then to go into slope intercept to standard, we have y equals 1/2 x plus 5. We're going to minus the 1/2 x, move that over because the x and y needs to be on the same side, plus y equals 5. Now Remember, my a, b, and c need to be integers, and this is negative integer, so that's bad. That's double bad. So we're going to multiply this by -2. And -2 will get rid of not only the negative, but that denominator. I multiply by a 2 in the numerator. We'll get rid of that 2 in the denominator, and that leaves me with x. And remember, I have to multiply everything by -2. So I'm going to multiply the y, so -2y equals -10. And now my a, b, and c are integers, and a is positive, so this is standard form. There are lots of different multiples of standard form, so this is not the only standard form that you can provide. You can multiply everything by bigger numbers and get a proportional value of that. Okay, now we got some fractions. Shouldn't be harder. Just got to slow down and make sure you do your work properly. So negative, let's do the slope first. -11/8 minus 3/4 over 1/2 minus 0. Okay. And that's going to be -11/8 minus 6/8 over 1/2. And that's going to be -17/8 over 1/2, which converts to -17/8 divided by 1/2, which becomes -17/8 times 2. And we're going to cross cancel. So my slope equals -17/4. That's my slope. Let's plug it into a point, and we'll get y minus -11/8 equals -17/4 times the quantity x minus 1/2. Now, all you have to do is simplify. I don't think y needs to be y. There cannot be a number. 11/8 equals -17/4 x minus 1/2. That is point slope form. That is one of them. Be interesting to see point slope. And now we're going to turn this into slope intercept form. So let's take that. Y plus 11/8 equals -17/4 over x minus 1/2. Y equals 11/8 equals -17/4 x plus 17/8. Let's minus 11/8 minus 11/8. And we get y equals -17/4 x minus 6/8. And we would reduce that. Y equals -17/4 x minus 3/4. That is in slope-intercept form. Be interesting if I got that right. Just such a weird, ugly fraction. And now we'll take this and turn it into standard form. So y equals -17/4 x minus 3/4. Let's add the 17/4 x over to the other side. 17/4 x plus y equals -3/4. And we're going to multiply everything by 4. Get rid of that denominator. Multiply everything by 4. And so that creates 17x plus 4y equals -3. And that looks nice and clean. That's standard form. 17/4 and -3. Let's see if that's correct. standard form. Uh-oh, I don't think it was negative. I don't think it was positive. Okay, maybe I made a mistake. Let's take a peek at that. Let's take a little look here. See where I maybe made a mistake. Negative 11/8 minus 3/4 is correct. 1/2 minus 0 is correct. That is negative 17. That's negative 6/8. Yes, that's correct. That's negative 17/8. That's correct. Divided by 1/2. It's just like multiplying by 1/2, which is correct. We have point slope. That plus, that's correct, minus your y sub 1 minus your x sub 1. Okay, ooh, maybe that's where I made a mistake. No, that's good, that's good. That absolutely made positive. We're subtracting that. Yeah, sorry. That's plus right here. That's plus 6/8. That's plus 6/8. Sorry. So this is plus. This is gone because it's positive. This is gone and that's positive. But they got 2. Well, did they get negative 17/4 and 3/4? Negative 17/4 and 3/4. Yeah. Okay, now let's check converting to standard then. Okay, taking that. That's correct, as we saw. We did that. We're adding 17/4 to y. Yes, that's good. We're going to multiply it by 4. That's how you get rid of the denominator. That, to me, is the standard. I know that there's multiple answers, but this is not proportional to what they said. So I think I'm right. I think they're wrong. Create an equation. Oh, parabola. Oy. Is that maybe what I did wrong? No, these are lines, linear. All right, parabola. I forgot to prep for this. All right. The slope is not going to be the same, but I think the vertex might be here. So let's do a little sketching. Negative 4, 9, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have negative 6, negative 6, 5, 6, negative 6, 1, 2, 3, 4, 5, 6. And then we have 0, 3, 0x. Okay. Well, I know it's a parabola, right? We know it's a U. The vertex is somewhere in there. All right. Well, let's do it on the run here. Let's see how. Let's learn while we're going. How do I write an equation for a parabola given 3 points? Okay, use the standard form of the quadratic equation, substitute the coordinates of each given point in the equation, creating a system of 3 equations, and then solve the system following, and which you give the equation of the parabola. Oh, that's kind of cool. Okay, I never knew that. So you're plugging in x and y into each of those. Yep, y sub 1, good, blah, 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 and then you solve the system. All right, let's see how we do, kids. Let's see if Mr. Mac can solve this on the go. So equation 1, we'll write in black. the equation is y equals ax squared plus bx plus c. That's a quadratic equation. So my y is -9 equals a times -4 squared plus b times -4 plus c. So that's -9 equals 16a minus 4b plus c. Okay, now let's use the next equation. Yeah, we'll use the next equation. So -6 equals a times -6 squared plus b times -6 plus c. Okay, that's -6 equals 36a minus 6b plus c. Let's do the third formula, which is 3 equals a times 0 squared plus b times 0 plus c. Okay, that's nice. So that simplifies to 3 equals c. All right, so we know that c equals 0 or 3. Now we can go back here and substitute that in. So we get the equation negative, I'm going to move it up a little bit. Let's put it up here. So -9 equals 16a minus 4b plus 3. And now let's move that over. So we'll subtract 3. We get -12 equals 16a minus 4b. And now we'll take this equation and we'll do -6 equals 36a minus 6b plus 3. We'll subtract 3 from both sides. That's -9 equals 36a minus 6b. And now we have two equations. So let's take those. Let's just take them. Can I copy? Copy. Let's create a new page. Let's paste. And we'll erase. Let's take this equation. Oh, I didn't mean to erase. Let's take this equation. Copy. Paste in the other page. Paste. Let's erase all this other. Okay, we have our two equations. And now we're going to use systems to eliminate. So I want to cancel. Let's cancel the b's. So we will multiply this by 3 and this by -2. And we'll move these actually over. And that will create two new equations. And everything multiplied gives you -36 equals 16 times 3. I should know 16 times 3, 48. 48. A minus 12b. Let's multiply this. And we get 18 equals -72a plus 12b. That's why we wanted to cancel the b's. We're left with, we're going to add these two. That's equal to -18 equals, and that is going to be -7248, 6, 4, 24. A. And now let's divide by -24, divide by -24, and that's going to give us -6 goes into that, no, +3/4 equals A. Pretty sure that was it. And now we can take either of these equations. Let's take the top one, -12 equals 16a minus 4b, and we'll plug in the a, which is 16 times 3/4 minus 4b. Cancel. Negative 12 equals 12 minus 4b minus 12 minus 12, negative 24 equals negative 4b. Divide by negative 4, and we get b equals 6. So I have my A, B, and C. So taking this, let's copy. Let's put that back down here. Let's paste. And let's copy my B. Let's paste that. So my equation is going to be y equals 3/4 a squared, no, x squared, sorry, my bad. 3/4 x squared plus 6x plus 3 is the equation that holds those numbers. Let's take a peek. Minus 6x plus 3, did I get that? It looks like it. Minus 6x? Did I do minus 6x though? I don't remember having minus. No, where did I mess up on that one? Let's see where I messed that one up. That's correct, so 3/4. Did I mess that starting equation? Negative 12 minus 4b. 4's cancel. 12 minus 12, that's a negative 4b. Makes a positive 6. Unless I made a mistake in the 4b, negative 4b. Did I make a mistake in the negative 4b? No, negative 4. What's this one? Negative 4b. That's correct. Well, here's what we can do is we can take, watch this, what we'll do now is we'll go to Desmos. Let's do Desmos. Let's enter in my equation, y equals 3/4 x squared plus 6x plus 3. Okay, they think it's, oh, sorry. Nope, don't want that either. They think it is negative 6x. I think it's positive 6x. So we want to see if these points, negative 4, negative 9, negative 4, negative 9 is one of the solutions. Negative 6, negative 6 is a solution. And 0, positive 3 is a solution. So my equation is correct. Theirs is wrong. Because if you put a negative, that like they have, let's see what it does to the graph. Negative. Yeah, it shifts it all the way over. And negative 4, negative 9 would not be a solution. You're wrong. You are wrong. That is incorrect. God, I mean, do these people not even check? That needs to be a positive. These people don't even check their answers. It's kind of, let's make it plus. How am I going to notate that? Let's do this. That's a positive. All right, so, but that takes some time. And we'll do it for these ones also. Is there another way we can do it? Create the equation, the parabola. I wonder if there is another. That's one technique, which I like. I mean, that was good. That wasn't impossible. It definitely took some time. Let's see this guy. Yeah, he's got 3 equations. Okay, given 3 points. How to find equation, 3 points. Substitute. Yeah, they're using substitution. How to find equation from coordinates. Yeah. Coefficient substituting coordinates into P. H, your shift. Yeah, I mean, well, you have the vertex. All right, so you could, maybe if you know that it's a vertex, do we know that this is the vertex? Yeah, so if we graph this, -5, 0, -5, 0, and +3, 0. Yeah, so we know. So we know where the axis of symmetry is because they're going to be equidistant. So that sum is 8, so it's 4. So the axis of symmetry is going to be -1. Okay. So my vertex is going to lie on that -1, but I don't have my vertex, and that doesn't necessarily show. I have 0, 30. 0, 30, so it's going to be upside down. It's going to have a negative a value. And I know that the other point is here. No, that didn't really help me unless I have the vertex. I know that slope, but no. I think I'm just going to continue plugging in and doing that other technique. I mean, it's time consuming and not very conducive to academic decathlon in the efficiency purposes, but I'll look into this and see if there's an easier way of going about plugging in these points. But let's move ahead. 0 equals, again, we're using this. We're plugging in ax squared plus bx plus c. So we have a times -5 squared plus b times -5 plus c. So 0 equals 25a minus 5b plus c. Let's plug in this one. So that is also 0 equals a times 3 squared plus b times 3 plus c. 0 equals 9a plus 3b plus c. And here we have 30 equals a times 0 squared plus b times 0 plus c, and we get 30 equals c. So we can again plug it in and get a new equation. 0 equals 25a minus 5b plus 30. So we're going to subtract 30 from both sides, and we get -30 equals 25a minus 5b. Let's do that for the next one. So we're going to plug in. We have 0 equals 9a plus 3b plus 30. Let's subtract 30 from both sides. -30 equals 9a plus 3b. Let's take those two equations. Instead of cutting and pasting and erasing, let -30, 25a. Sorry, nope. I need a new page. -30, let's move you over, equals 25a minus 5b, and -30 equals 9a plus 3b. 9a plus 3b. Yeah, I still like getting rid of the b's first. We can multiply this by 3 and this by 5, and the new equations are going to be -90 equals 75a minus 15b. This new equation is going to be -150 equals 45a plus 15b. My b's cancel, and I'm left with -240 equals 120a. Yeah. Divide by 120, divide by 120, negative 2 equals A. So I have my A, I have my C value, and now I'm going to go and plug it into one of these other equations. Let's take negative 30 equals 25A minus 5B. Negative 30 equals 25 times negative 2 minus 5B. Negative 30 equals negative 50 minus 5b, add 50, 20 equals negative 5b, divided by negative 5, and we get negative 4 equals b. So my A is negative 2a, negative 2 equals a. I don't like that, that looks weird. And my b is negative 4. B is negative 4. And negative 4 equals b. So my equation is going to be y equals negative 2x squared minus 4x plus 30. And let's make sure that that is correct. Negative 2, negative 430, negative 2, negative 430, negative... oh, okay, okay. They put it in... I see what they did. We were given the... there you go. Here's our other technique. We were given the zeros. We were given the x-intercepts. So these are x-intercepts. Let's take this. Let's do that. Technique C. Let's add a page. Let's retry this. So intercept is going to be for a parabola is y equals a times x minus, it's kind of like intercept 1, intercept 2. It's not h and k because h and k deal with the vertex, and we don't have the vertex. So I know my y is going to be 0. I don't know what my a is. I know what my x, no, this is going to be my minus negative 5. This is going to be x minus 3. And then I get 0 equals, I wonder how I get the a. How do I get the a? X plus 5, x minus 3. Okay, yeah. Okay, and then, oh, maybe you plug in this other point. Oh, yeah. Let's plug in my other point. So these, let's see if this let's see if this works. So this goes in for this. This goes in for this. And then we're going to take these two pieces, and plug them in for the x and y. So my y is 30, 30. My x's are zeros. So let's put zeros in for my x's. 0, 0, 0, 0. So 30 equals a times 5 times negative 3. 30 equals negative 15a divided by negative 15. And I get negative 2 equals a. So yeah, that is my, and then I have, so I can write it in this form, and it is going to be y equals negative 2 times the quantity x, what I have, plus 5, x minus 3. Is that what that answer was? Is that what it was? Positive 5, negative 3? Yeah, okay. So I'm not saying that that's necessarily any easier. Positive 5, yeah. Positive 5, negative 3, yeah. And if I simplify that, I will get this equation. This factors, actually, I guess we should have factored out a negative 2. That's actually not a great equation. You factor out a negative 2 from, oh, no. Divide by, no, that wouldn't work. This is okay. And here, let's use Desmos again. So let's take these two equations. Desmos, let's write y equals negative 2x squared. What was it, minus 4x plus 30? I think that's what it was. Minus 4x, yep. And now let's see if those points are on there. So are the points negative 5? Yeah, negative 5, 0, 3, 0, and we had 30, 0, 30. Yep, so that worked. That equation actually represented. And then if you have the equation y equals negative 2 times x plus 5, x minus 3, these, oh yeah, it's still it. Still the same thing. Still, those are still solutions. 0, 30, negative 5, and 3, 0. So these are the same equations. If we simplify, if we multiply that, distribute it out, you get the same equation. So, all right. Well, now you have another way of doing it. Now this only works when you're given x-intercepts. So be careful of that. This works because you are given the x-intercepts, and that will be beneficial. So let's do this. X-intercepts. All right, so that's good. That's a nice one. And now we're given the vertex. So now we can use the vertex equation, which is y equals a times the quantity x minus h plus k. I think it's that. Where you plug in, and now we're given a point. We're given the vertex, so the point will plug in for 0. We'll still solve for a. X is 8 minus my h, k. So minus 6 quantity squared minus 2, or plus negative 2. All right, let's simplify this. This is a, that's 2. We don't square until we simplify. And 0 equals a times 4 minus 2. So 0 equals 4a minus 2, add 2. 2 equals 4a. So a is going to equal 1/2. 1/2 equals a. Okay, and now we write our final equation. Y equals, was it negative 1/2? Positive 1/2. Y equals 1/2 x minus 6 quantity squared plus 2. That should be our solution. That should be the equation. Let's take that equation before we check the answers. Let's just check in Desmos. Let's see if, so y equals 1/2 times, oh, did I do, I don't know if I wrote squared, sorry. Yeah, I did. X minus 6 quantity squared plus 2, did I say? Plus 2. Okay, now let's see if the points, the proper points, 6, negative 2, and the point 8, 0, so that did not work. Mr. Mack messed that up. Is it minus k? Oh, minus k maybe. Minus k. That's probably where, oh, no, I probably messed that up. All right, so let's fix that. That might be minus k, that starting equation. So this is going to be plus, this is going to be plus, plus. That ends up being minus, minus. That's minus, that's minus, that's minus. That's minus. This is going to be minus. I think that still ends up being plus 2. I kind of knew, right? I mean, I think, well, let's see. Let's see if that fixes it. I do minus 1/2. Let's check. What are my 2 points? 6, -2. No, 6, -2 is still not. That's got to be, and this has to be -6, -2. No, that's -6, 6, 6, -2, 6. So that is correct. 6, -2. So, yeah, oh, maybe I did, right? So maybe it is. So this is the opposite, and then this is actually positive. So that's positive. Okay. So if that's positive, you plug it in, this ends up being positive. I mean negative, excuse me, because it's not going to change. This definitely changes. We're good with that. This goes back to negative. This goes back to negative. This goes back to negative. Positive, positive. That goes away. This goes away, so it's not upside down. And this needs to go to negative, because that's what my K value is, negative. This is the opposite of my H value. So that is your correct equation. Let's check it out. Make sure. Let's take the negative out of there. Boom. Okay. There's my vertex that is correct. And then we said 8, 0. Oh, yeah. All right. Well, that wasn't very efficient. But that is an equation that is my vertex form for a quadratic formula. Let's go here. Quadratic form, vertex, quadratic vertex form. That's, yeah, it is. Minus h, k, positive k. So, yeah, minus h, positive k. My bad. Sorry about that. All right. Boom. Given the table, determine linear or quadratic. So we know linear equations have constant slope. Quadratic have nonlinear. So we're just going to look at the difference. And so how do we go from -2? That's +3. How do we go? That's +1. How do we go here? That's going to be minus 15, and this is going to be minus 5. Yeah, minus 5. So now we have to take our y's over our x's. So that's going to be -15 over 3. And then our y's over our x's for the other one is -5 over 1. And this gives us a slope of -5. This gives us a slope of -5. Those slopes are the same, so it is going to be linear. And if we plotted those points on a graph, we would notice that they would create a straight line. If we plotted, let's show that in Desmos. So if we plot this, if we make a point, what are my points again? -2, 7, -2, 7, 1, -8, and then my third point is 2, -13. We look at that and we notice that we can probably draw, hopefully we could draw a line in between that. So you could, the slope, we know what the slope is, y equals -5 x, and then we don't know, -8, 13 plus 13, no. What did we do there? That is, plug in your x. Oh, that's 3. No. Oh, -3. Hello, Mr. Mac. Yep. Good. So notice it does cover those, and that would be the equation. They are all in a linear equation. That's above and beyond, but pretty good. I was plugging in points, and I didn't plug in very well. -4 to -2 is going to be +2. -2 to 0 is +2. -3 to 5 is going to be +8. And then 5 to -3 is going to be -8. So the slope is 8/2 between these two, which is 4. And then the slope between here is -8 and 2, which is -4. So it is nonlinear. It's a quadratic equation, nonlinear, because it doesn't have a constant slope. Okay, that's a nice fun one. And that's it. Let's see, make sure our answers are correct. Oh, and determine the equation. Okay, so we got the equation, didn't know that was part of it, and now we got to write the equation for this one. All right, so it's the same thing. Here are 3 points. We have, we do have the two. Oh no, we don't have. We have equal distance. We can tell. Okay, I'm just going to write 3 equations. Was it? What form was it? Yeah, it is in. Okay, so we'll do that same thing where we have points. Let's do it. So -3 equals, we're using the equation y equals ax squared plus bx plus c. And let's do the first point. So the first point is going to be -3 equals a times -4 squared plus b times -4 plus c. And that gives us -3 equals 16a minus 4b plus c. Let's do the next equation. That is going to give us 5 equals a times -2 squared plus b times -2 plus c, which simplifies to 5 equals 4a minus 2b plus c. Just checking our work, we're good there. And then our last equation is going to use the point 0, -3. So -3 equals a times 0 squared plus b times 0 plus c, which simplifies to -3 equals c. We love it when we get those ones. And now we're going to plug that back in and get new equations over here. -3 times 16a minus 4b. What was c? c is -3 minus 3. We're going to add 3 over. That is 0 equals 16a minus 4b. Let's do the blue equation. And that's going to be 5 equals 4a minus 2b minus 3. We'll add 3 to both sides. That gives us 8 equals 4a minus 2b. Those are my 2 new equations. We're going to do systems of equation. We'll do that on another page. And that other equation was 16a minus 4b. 0 equals 16a minus 4b. Move you over. And my other equation, 8, 4, -2. 8, 4, -2. 8, 4, -2. Let's multiply. That. Let's get rid of the a's this time. We'll just multiply 1. That's the nice thing about that. We get 0 equals 16a minus 4b, so we don't have to do anything to that equation. That gives us -32 equals -16a plus 8b. The a's cancel this time. -32 equals 4b, divide by 4, divide by 4, -8 equals b. Okay, let's transfer that over while we're remembering. -8 equals b. And now let's solve b, so 0 equals 16a minus 4b, plugging in. 4b is negative 8, 0 equals 16a plus 32 minus 32 to both sides. Negative 32 equals 16a, divide by 16. And we get negative 2 equals a. Let's transfer that over. Negative 2 equals a. And we have our final equation. Y equals negative 2x squared minus 8x minus 3. Is that the equation? Negative 2, negative 8, negative 3. Negative 2, negative 8, negative 3. Let's go. All right. That's good. That's a very, I mean, I don't really use that often. That is definitely the tail end of Algebra 1. You'll definitely utilize that in Algebra 2 when you take that. So that's good. It's good to know how to manipulate equations plugging in points. Have a good one.